for us at Unity, it's such a big, important step up to make sure that the visual control of what your material, don't mind me, these guys, look at me, that the visual control of what your material looks like, what your game looks like, is in the hands of artists like Franz and like Jed, where it belongs. Now, we've been looking at a few mobile titles that use the lightweight render pipeline, but the lightweight render pipeline is also the thing that powers our AR and VR features. So let's take a look at some of those.
Please welcome Brittany Edmond and Dan Miller.
Dan, when they told us to make ourselves at home up here, I don't think they meant to bring your living room.
Huh. Well, might as well take advantage of it.
I guess.
It's an exciting time for augmented reality, with new features and technology being released for both handheld and wearable platforms.
And people are getting used to the idea of using their phones for more. From using them to take pictures with dinosaurs at the park, to visualizing what furniture could look like in their homes before they purchase it. We're really just starting to scratch the surface of the potential of this technology.
And at Unity, we want to give you the resources to stay on the bleeding edge of augmented reality. Today, we'll be talking about AR Foundation.
We built a framework specifically for AR creators that gives you the ability to build your application once and deploy across both ARKit and AR Core enabled devices. We've also included additional features to help you overcome some of the other common challenges of AR development, from anchoring your digital object in the real world to the visual fidelity of those digital objects and more.
We've taken assets from the FPS sample and converted them from the HD render pipeline to the lightweight render pipeline, since we're targeting mobile devices.
And in playing with these assets, we're going to show you some of the features that you can take advantage of with AR Foundation by demonstrating how you can take assets that you've already created for your non-AR project and use them to create an AR project that looks great, runs smoothly, and is available on the 1 billion mobile devices that are AR-enabled around the world today.
And enabling AR Foundation in your editor is as easy as going to the package manager. Since we've already done that, we can go ahead and hop in. Today, I'm going to be using a feature called AR Remote, which allows me to connect an AR-enabled mobile device to the Unity editor. From here, we can start placing content in the world and building, iterating, and developing without having to compile out to the device every single time.
Dan is able to place content directly onto planes in the real world by clicking his mouse in the editor. Seeing these types of changes in real time will save you a ton of time as you're working.
I'm using something called AR Foundation Samples, which is a collection of assets and resources already put together so that you can start building in augmented reality today. Let's go ahead and replace those spheres with an instance of our Terraformer character and see what she looks like on the stage. Now, restarting the remote is as simple as hitting the play button.
And as Dan's working, you're noticing the blurriness in the camera feed in the editor. This is because we're using something called the downscale factor, which lowers the resolution of the camera. But on the flip side, it gives us a little more performance as we continue to iterate.
And our character's looking good, but she's not fully matching the lighting that we have going on stage. To solve this, we can use light estimation, which is a fundamental technology of ARKit and AR Core, but they both do it a little bit differently. Because we're using AR Foundation, we can simply enable this once and have it work across both platforms. Let's go ahead and look at what she looks like now. You can see now she's a little bit brighter because of the stage lights, and if they dim, then she gets a little bit darker too.
And I want to make sure that you don't miss that Dan has been working directly in the Unity editor, because AR is just another build platform for Unity. And all of the workflows and the features and the new tech that we're building, from the lightweight render pipeline to the entity component system, all work for mobile AR.
And you can see how seamless of a process it was to take assets you've created in Unity and bring them into augmented reality. And we spiced up this demo a little bit more than just placing a character in the scene. So Brittany, why don't you go ahead and grab the iPad and show them what we made.
Absolutely. So we created a custom sequence using Timeline that allowed us to add in a couple of these extra cool moments that Dan just referenced.
And one thing I want to highlight is that Brittany is now using an ARKit-enabled iOS device. Before, we were developing on an AR Core-enabled Android device. Switching between ARKit and AR Core is as easy as switching build targets in Unity. AR Foundation does all the heavy lifting. Huh, what do we got going on upstage?
You know, I just thought it would be a nice touch if we added a couple plants from our terraformer's home planet before we welcomed her on, just to make her feel a little bit more welcome. So now, let's welcome her on.
Whoa. She's a little bit taller than I expected.
Do you want to see something cool?
Sure. Whoa, where'd she go?
Oh, she's still here. Notice that even though she's transparent, you can still tell where she is on the stage because of the way that her body warps the digital and the physical objects behind her. Also, I want to point out her shadow. When she's transparent, she doesn't have one. But if we bring her back, notice that not only does she have a shadow, but it's a shadow of her actual body. It's not just a blob. Unity gives us the power to make these seemingly tiny creative decisions that actually have a big impact on making our terraformer feel like she's actually in Dan's living room with us.
And I'll be perfectly honest, I don't really know how to program shaders. This effect was all created using the visual node editor available in ShaderGraph. Since we're using lightweight render pipeline and AR Foundation, we're able to easily pull in the camera feed into a node to create many cool visual effects like this and more. And whoa, those are the spaceships from Megacity rendering in AR? How many of them do you even have?
3,000, 4,000, 5,000, 6,000, 7,000.
Okay, Brittany, I think we get the idea.
The idea I really want to land here is that the reason why we're able to get so many spaceships working in AR is because we're taking advantage of the data-oriented tech stack, which also allows us to really take advantage of the hardware that we're using.
That's pretty impressive. Over 7,000 unique entities, all rendering in AR at a solid 60 frames a second. I think you can tell that with the power of Unity and AR Foundation, you can build some really cool
stuff. Some really cool stuff.